Dear friends, in this tutorial, we will learn about clipper circuit. These are the points covered in this tutorial. A clipper circuit is used to cut a portion of the input signal, without distorting the remaining part of the input alternating waveform. A half-wave rectifier, in the previous tutorial, is the simplest form of clipper with one diode and one resistor. Depending on the orientation of the diode terminals, either positive or negative part of the signal is cut off. There are two types of clipper circuit: series and parallel configuration. In a series clipper, as shown in the figure 16.1, the diode is in series with the load. The response of the circuit is shown in this figure. The output is similar to that of sinusoidal waveform, in the case of half-wave rectifier. Also, there are no boundaries for signals that can be applied to a clipper circuit. Figure 16.3 shows series clipper with DC supply voltage of magnitude, capital V volt. Here, voltage V means that the input voltage must be greater than V volts to turn the diode on. For the negative half cycle, the diode is in off state, which is supported by the DC supply. Now, we will determine the transition voltage of the applied voltage for which the diode state changes. Applying VD equal to 0, and ID equal to 0, for the transition stage, as shown in this figure 16.4, we have Vi equal to V. For an input voltage greater than V, the diode is in short circuit state. But, if the input voltage is less than V volts, the diode acts as open circuit. When the diode is in short circuit as shown in this figure, Vout can be calculated using the Kirchoff voltage law. The instantaneous value of the output is also shown. The input can be treated as a DC supply of that value, and the corresponding DC level of the output is determined. For an input voltage Vm greater than V, the diode is short circuit, and the output voltage becomes Vm minus the fifth. The analysis of the parallel configuration is similar to that of a series configuration as shown in this figure. The input and the output waveforms are shown. Thank you for watching the video. If you find it beneficial, please like, share, and subscribe to my channel. I would also like to have comments if further modification is required.